Hello friends, so today we are going to learn satellite based positioning. It is unit 3 chapter 4. So let's start satellite based positioning. So what is satellite based positioning? Satellite based positioning, it was developed initially for the military needs. Like we know internet was previously developed only for the military needs, and later on people started using it for their day-to-day activities. Same way satellite was also developed only for the military needs, so that we can exactly find out the position of any object on the surface of earth. So it is suitable for all kind of military use like ground troops, vehicle, aircraft, missiles and ships. So it requires low cost equipment with low energy consumption at the receiver end. Now, what is the importance of this? That we can actually find out the position of an object on the surface of earth through satellites, but we cannot use just one satellite. We have to use 2, 3 or 4 satellites to exactly locate the position of any object or any device on the surface of earth. So provision of result in real time for unlimited number of users concurrently was provided in the satellite based positioning. Support for different levels of accuracy, because for military we require accurate position, whereas civilians can have a little bit less accuracy. Then round the clock and weatherproof availability. So the availability of the data should not depend on the cloudy weather, and use of single geodetic datum for the entire world. Protection against intentional and unintentional disturbances, for instance through a design allowing for redundancy. So all these were the requirement of a satellite based positioning. Now, a satellite-based positioning system setup involves implementation of 3 hardware segments. We require the 3 segments. One is the space segment, the control segment, and the user segment. The space segment is the satellite that orbit the earth and the radio signal that they emit. That is the space segment. So satellite will emit the radio signals. Then the control segment is at the ground station. So the ground station that monitor and maintain the space segment, we call it as the control segment. So it is basically on the surface of earth. We have the ground stations which will be monitoring the satellites, and we have the user segment, the user with their hardware and software to conduct positioning. So it may be the mobile phone, it may be the any other device with which the user will be tracked on the surface of earth. Then absolute positioning. Absolute positioning means we are working on the absolute positioning technique, which is actually very simple. Here a satellite is equipped with a clock, and a specific moment sends a radio message that includes the satellite, the identifier, its position in the orbit, and the clock reading. So every signal will have 3 information. First information will identify the satellite, then second will identify its position in the orbit, and third will identify the clock reading. A receiver above the planet, also equipped with a clock, receives the message, but it receives the message slightly later and reads its own clock. From the time delay observed between 2 clock readings, and knowing the speed of radio transmission through the medium between the sender and the receiver can compute the distance to the sender and also the satellite pseudo range. So the pseudo range of a satellite with respect to receiver is its apparent distance to the receiver computed from the time delay with which the radio signal is received. So suppose there is a satellite and the satellite is sending signal to the earth. So what is the time delay? Based on that, the position of the distance between the satellite and the receiver is calculated. So this is how the pseudo range of the satellite is created. Now this pseudo range is used to identify the position of the satellite. So let's see next. Next we see a video on trilateration. So please watch the video carefully. This video I have taken from internet. So
how GPS works. Trilateration explained. Have you ever wondered, how does the global positioning system work? I guess you did if you're watching this video. GPS uses a method called trilateration. It seems to be widely confused with triangulation, but triangulation requires measuring angles, while trilateration is based upon measuring distances. I'll show you this using a simplified two-dimensional visualization. Let's say we have three transmitters, A, B, and C. They form a triangle. However, they will be able to locate an object not only inside of the triangle, but anywhere in their range. So let's start by measuring the distance to the satellite A. I'll illustrate the measured distance with a circle. I'm not going to show you the receiver yet, because it will be easier to understand how GPS can determine your position without seeing you. So here we are. We've detected that the distance from the receiver to the transmitter A is equal to the radius of this circle. This means that our GPS receiver is located somewhere on it, but we need more information to be sure exactly where. Right now, it can be almost anywhere. Let's now measure the distance to the transmitter B. This should vastly increase our positioning precision. Now, the circles intersect in 2 points. This means that our lost traveler can be in either of these points. We're still not sure where exactly, but the third satellite named C should provide us with an answer. We're measuring the distance to the GPS receiver, and here we are. The three circles have only one common point. And if our detected distances are correct, this point of intersection has to be the location of our receiver. And it really is. Neat. But how does GPS actually measure distances? Let's see. GPS satellites constantly broadcast two pieces of information: their own location and their current clock time. Because the electromagnetic waves that are used to carry this information through the space travel at a speed of light, one can measure a distance using a stopwatch. Well, if it's quick enough to tap it twice in a millionth of a second with precision. Let's say that at this moment all devices, the satellites and the receiver, have synchronized clocks. I'll illustrate the time on a timeline. At the beginning of our timeline, every satellite sends out its own position and time. But before this information reaches the receiver, it's already outdated. I'll mark the arrival times with letters on the timeline. Now the receiver knows where and how much time away from it every satellite is to be found. Multiplying this by the speed of light easily gives us the distance instead of the time. Now, finding the common point of all three distance circles and taking into account the locations of all satellites will give us our own location. And this is how GPS is able to measure distance using a clock. Of course, in real world, this all happens in a three-dimensional instead of a two-dimensional space, so it's a bit more complicated, but the basic principles are the same. I hope you've learned something useful. Thanks for watching.
I hope you watched the video carefully and you are able to understand that how it works in three-dimensional. But we have shown you two-dimensional. Now you can easily assume that how this will work in three-dimensional as well. So for three-dimensional, what will happen, instead of showing a circle, what we can say is, if one satellite will create a space, means it will create a sphere around it. Now, if we take the readings of another satellite, then the sphere of the two satellites will coincide with each other, and these are the points where they coincide. So, these are the points if it's two-dimensional, but if it's three-dimensional, then we will get a circle of this type. So, this type of circle will be the intersection of two spheres of the satellite pseudo range. Now we will see the trilateration process. If the third satellite image is also taken, then what happens, the intersection of three spheres, it will determine two most likely positions. So three circles, now I'll show you in this diagram that we have two satellites and one circle is formed. So if we take another satellite over here and we try to find out its circle, so what will happen? The pseudo range will again cut at a particular two different points. So out of these 2 points, what we can find out is one point will lie on the surface of Earth, whereas the other point will lie far apart from the surface of Earth. So the point which is close to surface of Earth, this point may be the most likely position, whereas the other position is most unlikely. So the most unlikely position can be directly rejected. So with 3 satellites, we are able to find out or locate the position of any receiver on the surface of Earth. Then comes clock bias. So satellite clocks are costly, high precision, atomic clocks that we consider synchronized for the time being, but the receiver typically has far more cheaper quartz clock, and this is not synchronized with the satellite clock. So this brings into play an additional unknown parameter, namely the synchronization bias of the receiver clock. That is the difference in time reading between it and the satellite clock. So if there is a time difference, then this clock bias, that is the time difference, needs to be stored, and that has to be deducted while we are doing the calculations. 3D positioning. So our set of unknown variables has now become x, y, z and delta t, representing a 3D position and a clock bias. By including the information obtained from 4th satellite, we can solve this particular problem. If we want to find out any object, if this is our Earth and we want to locate the objects on the surface of Earth, that is two-dimensional, but if the object is present at a certain height, okay, so we have to consider also the height of the object. So we have to consider 3 parameters, x, y and z, and we have to include 4 satellites to find the height of the object. So this is the pseudo range of 4 different satellites. So using 4 satellites, we can even find out what is the height of the object from the surface of the Earth. So 4 satellites are needed to obtain a 3-dimensional position. Pseudo range are indicated for each satellite as dashed circles represent the sphere as well as the actual range. So the 4 satellites each have their own pseudo range. If they all intersect, then we are able to get the height of the object. 2D positioning mode we'll discuss in the next video. Thank you.